In this video, I'm going to share everything I learned when preparing to install a new stereo system in my truck. At the beginning of this project, I had zero experience with car audio, but after watching dozens of YouTube videos, I was anointed with the confidence to tackle an intimidating project such as this. This video is for those folks who don't have any experience with car audio, but want to learn the basics so they can attempt to build the stereo system of their dreams for their personal vehicle. For the car audio professionals watching, please comment below where I could have done better or alternatives to the solutions I came up with during my build. I don't know everything, but I wish I did. Lastly, before I start, I'm going to cover as many topics as I can, but in a short amount of time. Whatever topic or problem I don't cover long enough in this video, I'm sure you can find a more in-depth explanation somewhere on YouTube or the internet. 90% of the work when it comes to building your new car audio system is designing your desired system on paper or on a computer screen. The first big hurdle to that, however, is just knowing how car audio systems work. I'm going to run through 5 typical setups, and hopefully from these diagrams you'll be able to see what kind of system you want. The first diagram is for a stock car audio system. This is how it comes from the factory. In this diagram there are only 4 speakers. I'm going to start at the radio and then work all the way to the speakers. Your stock stereo is going to be connected to a wiring harness and an antenna. Coming out of the radio might be a USB, so you can plug your phone in to play music or display GPS. That's really it. When I refer to the wiring harness, I'm referring to your car stereo's connector with the wires that run to the speakers and power. This wiring harness will have a bunch of different color wire that mean specific things. On my truck, here's what those wires mean. These wires are just the positive and negative connections for 4 speakers or 8 wires. This diagram shows how OEM stereos are connected to factory speakers, or if you install a aftermarket stereo and you still want to use your factory speakers, the diagram at the bottom shows you how that is done generally. Now I'm going to cover the first of many aftermarket builds for your stereo system. First is simply replacing your stereo. The biggest factor in figuring out if your new stereo will fit in your dash is figuring out if your vehicle will fit a single or double DIN stereo, or if it can fit both. Once you figure out if it will fit and how to mount it inside the dash, the next thing you need to do is find the wiring harness that will connect your new stereo to your vehicle's built-in wiring harness. If you still have your stock radio, you can chop off its harness and solder it to your new radio, or you can buy a new harness. Once you have matched wires and soldered them together, you can plug in your new radio and everything will work. So why would you just upgrade your stereo? Well, aftermarket stereos might give you more features than your stock radio. They might also provide more power through a built-in amplifier. But again, your stock wires are only so big. You can also just replace your speakers and keep your stock radio. Just pop off your door panels and disconnect the wires. There are special connectors you can buy that will solder or butt join your stock wires and connect to your speakers. When picking speakers, your biggest concern is size. Just find out what size fits in your vehicle and buy aftermarket speakers in that size. Aftermarket speakers are also measured in how much wattage they can handle. I wouldn't really worry about this number, especially if you're still using your OEM stereo, because more than likely your OEM stereo will not put out more power than what most of your aftermarket stereo speakers can handle. It's only when you start using aftermarket stereos is when you have to compare the output, the wattage output of your aftermarket stereo to what your 4 speakers or 6 speakers are going to handle or need to handle in relation to this new aftermarket stereo. The last upgrade is changing both the stereo and the speakers. Will it make a difference? Most definitely. You'll get more features out of your radio if you're buying a radio that has more features than your stock radio. I keep mentioning features, but I haven't told you what features you can get out of an aftermarket radio. These can include Apple CarPlay or Android Auto. You can also get a backup camera or a simple Bluetooth connection to your phone to play music or make a phone call. For Apple CarPlay, you got voice to text as well, which is just texting people with your voice. But back to just simply changing the radio and the speakers. Will it make a difference? Yes, but not as much as you think. The single component that will remain the same is your speaker wire, but I'll talk more about this later in the video. Now I'm on to my second diagram, a single channel amplifier. This is actually the setup I had in my truck for more than 10 years, and it was great. Before I continue, let me answer the question, what is an amplifier? It increases the power of a sound signal. Why is this important? It can make your sound system louder and, more importantly, make it sound clearer. You can use a single channel amplifier in multiple ways. You can use it to power all 4 speakers, or you can use it to power one or multiple subwoofers. I used my amp to power one 10-inch subwoofer, but I was also using an aftermarket stereo. The stock wires and speakers sounded great. The added amplifier and subwoofer made the entire system better. I highly recommend this be your first setup because it was cheap, between $500 to $1,000, but will drastically improve the sound of your system compared to a stock system. Let me run through this example. The car stereo uses factory wires but also sends signals to the amplifier using RCA cables. Some car stereos use a single port for RCA, but others will use both. This RCA cable connects to the amplifier and sends the subwoofer signals. This remote wire is connected from the stereo to the amp, and it tells the amp when to turn on. The amp receives power directly from the vehicle's battery and grounds to a spot as close as you can get it to the amplifier. The amp then connects to the subwoofer using speaker wire. The next setup I want to show is a 4-channel amplifier, 1 channel per speaker. This setup is dynamic, meaning it sounds much more realistic than just having one single channel feeding 4 speakers. It also means each speaker is getting more power than from 1 channel. There are 2 ways you can connect your speakers to your 4-channel amplifier. You can use 8 aftermarket wires, 2 per speaker, to connect to the amplifier. You can also use Speedwire, which connects your amplifier to your vehicle's audio harness. This allows you to use your stock speaker wires. Speedwire is just a thick bundle of 9 wires. 8 wires are for your 4 speakers, and 1 wire is to allow your stereo to communicate to your amplifier. This is called the remote wire or amplifier turn-on wire. Will you get better audio quality with an amplifier and stock speaker wire compared to just stock stereo and stock speaker wire? The answer is yes. The last setup I want to talk about is the 5-channel amplifier. It powers all 4 speakers and 1 subwoofer. This is the setup I'm doing for my truck. I'm going to stop at the 5-channel amplifier for this video, but keep in mind that there are much more complex audio systems than this. You can always add more amplifiers, more subwoofers, and speakers to a car audio system. This means you need more power for your vehicle, however, so you might have to add more batteries into this giant setup, or add more alternators, or upgrade your alternator to produce more amperage. This video isn't really about what brand is the best or what I recommend. Like I mentioned earlier in this video, first determine if your vehicle will fit a single or double DIN stereo. Next, determine what features you want from your stereo. Once you've picked your stereo, pick out your amplifier. The only way stereos communicate with amplifiers is through RCA cables. so you don't have to worry about power matching or cable thickness. Amplifiers are separate from stereos for the most part. So what that means is that any modern vehicle stereo system will work with any modern vehicle amplifier. But now we have to pick an amplifier that your vehicle can supply power to. First, determine how many amps your vehicle's alternator produces. We will use mine for example. My truck alternator can produce a maximum of 130 amps. Every alternator will have a amp rating, but this rating measures the maximum output. The actual amp output will vary, and this is dependent on what electrical systems are using power in your vehicle. If your vehicle is parked and is running on idle, then expect a low amp output from your alternator. If you have your AC going, the lights blinking, and your car stereo is playing music loud, then expect your alternator to be putting out more amps. The car audio amp I picked out for my build can pull close to 80 amps of power. So if I got the stereo system as loud as it could go, then that would leave only 50 amps for the rest of the vehicle. This is not a lot to leave for your vehicle, but keep in mind, I never play my music that loud, so it's not an issue for me. If you need more amps for your vehicle, you always have the option to buy an aftermarket alternator that can produce more amps than your stock alternator. Just do the math and research first. Aftermarket alternators are expensive. Unless you really need the extra amps, don't buy a new alternator for your vehicle. I get by with my standard stock alternator just fine. A decent way to determine if your alternator produces enough amps for your desired sound system is to first calculate the total watts RMS of all your speakers and subwoofers. Take the total and divide it by the voltage your battery puts out. The number you get is the maximum number of amps your audio system can pull at full volume. If that number is greater than 65% of your total amp output of your alternator, then you might want to upgrade your alternator to one that produces more amps. Later in this video, I'll show you how I calculated the 80 amps for my amplifier, but this leads me to my next point, matching speakers and subs to your amplifier. Every amplifier will tell you how many watts RMS it will produce at a specific resistance. Resistance is measured in ohms, which uses the Greek letter omega. It looks like a horseshoe. The lower the ohm, the less resistance in the electrical system. For example, my amp will produce 65 watts RMS per speaker plus 150 watts RMS for the sub at 4 ohms. Or it can produce 90 watts RMS per speaker plus 300 watts RMS for the sub at 2 ohms. By decreasing the resistance, you can increase the amount of watts that go to your speakers and subs. So now that you know how many watts your amplifier can produce, you need to pick out speakers that can safely use that amount of wattage on a daily basis. I fully intend on my setup being 2 ohms, so my amplifier will be able to produce 90 watts for the speakers. I found this pair of door speakers that are rated to handle 100 watts RMS, but at 4 ohms. So what does that mean? The speakers will handle up to 100 watts RMS at 4 ohms, but the amplifier can put out 90 watts RMS at 2 ohms. What's going on? The first concept I'll cover is a channel. Channel is a pair of positive and negative terminals. Not every pair of terminals is the same, and this is due to a range of factors such as the quality of the materials used and the sensors connected to the system that are between those positive and negative terminals. In my amplifier, one channel will support a minimum of 2 ohms. Anything lower will damage the amplifier, and anything higher is safe to use. The second concept I'll cover is wiring speakers in series or parallel. Most of the time, speakers are wired in parallel because it's a lot easier. Wiring speakers in series is much more difficult because you have to wire all the speakers together. Not saying it's impossible, but I'm sure it is not as common to see series wiring in vehicles. The importance between series and parallel wiring is series wiring increases the resistance or ohms of an electrical circuit. Parallel wiring decreases the resistance. When I plug one door speaker to a channel, the amplifier senses that the speaker has an ohm resistance of 4 and will only give it 65 watts of power. The amplifier can give more power, but it won't. Now, if I were to plug two parallel 4 ohm speakers to this one channel, the resistance will drop to 2 ohms and the amplifier will now push out 90 watts of power. But are both speakers receiving 90 watts of power now? No. The 90 watts is shared between the speakers. So in theory, each speaker is only getting 45 watts. The advantage is that you can place that second speaker somewhere else in the vehicle, and overall, your stereo system will be louder. So to recap, all my speakers are 4 ohm and they each get a channel to themselves. So they all get up to 65 watts each. My subwoofer, however, is wired for 2 ohms, and since it gets a channel all to itself, the sub can get up to 300 watts of power. After deciding what setup you want, you now have to plan how much wire you need and how thick the wire needs to be. First, map out where your stereo and speakers are and where you want the amplifier and subwoofer to be. Once you have a rough estimate of where everything will be in your vehicle, grab some string and start laying out the string in your vehicle to see how much wire you need. Use the string as a stand-in for wire, then measure the string once it completes the connection from your stereo to speaker, or from stereo to amplifier, or from amplifier to speaker. For every line you draw in your diagram, measure it out in your vehicle. For every wire run, I added an extra 24 inches just to be on the safe side. Now for wire thickness, there are 3 different wire sizes you need to account for. You have to calculate the wire thickness between your battery and your amplifier. You have to calculate your wire thickness between your amplifier and your speakers. And then lastly, you have to calculate your wire thickness between your amplifier and the subwoofer. I will cover the battery to amplifier wire first. The 2 big types of wire is copper clad aluminum, also known as CCA, and oxygen-free copper, also known as OFC. OFC is the superior wire, but it is more expensive. CCA is cheaper, but requires a thicker wire to handle the same amperage as OFC. Spend your money on OFC. Don't try to make a Honda into a NASCAR. For the following, I'm going to use my amplifier as an example. To save time, I won't define RMS watts, amps, or any other electrical term. I'll allow you to learn about that on your own. I'm going to be using 90 watts RMS times 4. This is for the speakers. The amplifier will also supply 300 watts RMS to the subwoofer. The total RMS wattage is 660 watts for all 4 speakers and the subwoofer. Now you need to know what kind of amplifier you're using. 2 common types of amplifiers are Class D and Class AB. Class D is 80% efficient and Class AB is 50% efficient. What this means is that a Class D amp will need 100 watts of power to produce 80 watts to the speakers or subwoofers. My amplifier is 2 amps in 1, so it is both a Class D and a Class AB. The amp used for the sub is a Class D, and the amp used for the speakers is a Class AB. I'm going to break up the 660 watts into its components. 360 watts are needed for the speakers, but since half of the amp is a Class AB, it actually needs 720 watts. The subwoofer can get up to 300 watts from the amp, but since it is a Class D, the amp needs 375 watts. So to calculate how many watts can potentially run through my amp, which is secretly 2 amps, it is 1,095 watts. Now that we have the maximum watts that an amp can push, we need to determine how many volts your vehicle produces. Mine typically produces 14.2 volts, and I have a trusty dial on my dashboard that tells me. But you can also use a multimeter to find this out too. Divide the wattage needed by the volts put out by your vehicle to determine the maximum amperage your wire needs to handle. In my case, it is 1,095 divided by 14.2, which is about 76 amps. Use this chart to determine what thickness you need depending on amps and the length of run of your wire. For me, my run was longer than 13 feet, so I used 4 gauge OFC to power my sub from my battery. For the cable run between your battery and your amplifier, it is common practice to install a fuse in this run. When installing your fuse, do it as close as possible to the battery. That way, if you do overtax the system and cause the fuse to blow, you only have to replace the short end of the cable run as opposed to the whole thing. When you blow a fuse in a system, it is reasonable to assume that you have also damaged the wire between the power source and the fuse. So, how do you calculate the kind of fuse you need in terms of amperage? You divide your total watts needed by the voltage of your vehicle. In my case, it's 1,095 watts divided by 14.2 volts, which is about 76 amps. Normally, you want your fuse to burn up at a lower amperage than this number, but I decided to go higher because a 4 amp difference isn't the worst. If I picked a fuse that burned up at 60 amps, then I'm losing 16 amps worth of power. But if I picked a fuse that burned up at 80, then I get to use all of the wattage for my system. Also, my amp has an internal fuse rated at 80 amps. This is another way to determine what fuse you need for your cable run between battery and amp. The amplifier manufacturers will do the math for you and build in the fuse into your chosen amplifier. Now I'm going to cover amplifier to speaker wire and amplifier to subwoofer wire. The typical wire gauges for vehicles can handle a wide range of wattage and ultimately amperage that you are putting through the wires. What you are paying for is how long the wire lasts. An 18 gauge wire cannot handle the maximum wattage a 16 gauge or a 12 gauge wire can handle, but they all can handle the typical wattage used in a vehicle's audio system. An 18 gauge can handle 90 watts RMS just like a 16 gauge or a 12 gauge. The only difference is that a 16 gauge and a 12 gauge can handle 90 watts for longer than 18 gauge before the wire gets burnt up. I used 12 gauge for both my speakers and my subwoofer because I want my wires to last for a long time. 90 watts RMS is the max my speakers can receive from the amp, but not the norm. So I'm confident my 12 gauge wire will last for many years before needing to be replaced. This topic is very complex, so please study wattage, amperage, and wire sizes more in depth before deciding on a wire size. If you're just looking for an easy answer right now, pick a wire size between 16 and 12 gauge. The thicker the wire, however, the longer the wire will last. I'm going to own my truck for the rest of my life, so using a 12 gauge wire is not an issue. I know I'm not answering a lot of questions you may have when it comes to wire sizes for speakers and subwoofers. but I will leave that to more qualified experts than myself. At this point, you have a diagram of your desired setup and wire length and sizes. It is now time to install everything in your vehicle. This will require a variety of tools that will allow you to run the wire through every crack and crevice until it reaches the spot you planned for. Here are the shots of my final install. I definitely did not buy enough wire, so I had to modify my runs to take shortcuts within my truck. The final product may not be as pretty as it could have been if I had only bought more wire, but I am proud of my first install and it works as desired. If you have any questions, please ask in the comments. I may not have an answer, but hopefully somebody with more experience will. If you don't understand a concept, then spend the time to learn all that you can from folks who have a strong grasp of it. I am not a car audio guy. I just like learning and pushing myself to learn more complex topics. I had the desire to improve my truck audio system, but I had little to no knowledge on how to do it myself. I made this video to not only share what I learned, but to also remember all the work I put into completing such a project. I don't do car audio every day, so after a few years, I won't remember how to install or upgrade my current system. But I'll be able to watch this video and get snapped back into the topics I need to know about before tackling another project as big as this. Anyways, thanks for watching.